difference between the definite and the indefinite integral. First, we have here the same formulas we have been using in the previous cases, and now I wrote here this couple of new formulas, which is basically the first one is so far what we have been doing. This is actually the general statement for an antiderivative, and also another way to call the antiderivative is by the name of indefinite integral. Now, the difference between the indefinite integral and the definite integral is the indefinite one, or the antiderivative, you get in return a formula, while with the second one, you get in return a numerical value. So this one, which is the definite integral, will give us in return a numerical value that stands for the area between the function and the x-axis for this interval, b and a. It's pretty much, well, basically, essentially the same thing as the Riemann sum. I'm actually using here an example that we solved previously using Riemann sums. I'm going to solve it now using this definite integral. But first, I'm going to solve the indefinite integral, and then I will show you the difference between these two in the process. So I'm going to do this one in will be 2 times the integral of x squared dx. Will be plus 3 times the integral of x dx, will be minus 2 times the integral here. These two will be like multiplying a 1. 1 is just the same as x raised to the 0 dx. So we solve this out, we will get to this 2 times x to the third, so very ugly 3, third over 3, will be plus 3 times x squared over 2, will be minus 2 times x, and here we plus c, and that will be it for the indefinite integral. Now I'm going to actually now solve it this same example, but I'm going to use this criteria for the definite integral. That is, we have to add an interval. I'm going to add the same that we used in the previous example, the example of Riemann sums, -1 to 5, and well, we'll see. We will get eventually, we have to do at least first, this step will be just the same in the second one. Actually going to write it here. I want to use different color, will be 2 times integral x squared dx plus 3 times x dx minus 2 times x to the 0 dx. Now the difference in the way you have to write it for the second step, I'm going to write it here, will be just the same as the previous one. It will look the same, the notation will be pretty much like this: 3 times x squared over 2 minus 2 times x, but here instead of writing the c, you will write it like this. You have to write a bar, which is where you're going to write the interval. Here -1, oops, that's very ugly, -1 here, and here the 5. So here's the interval. It's just a way to say you're going to evaluate this expression first on 5, which would be this part, and then would be minus evaluation of this expression with -1. So let's get to this. Will be equal to, let's see, will be, I'm going to use brackets to remain with more order so you see clearly what I'm doing. 2 times 5 to the third over 3 plus 3 times 5 to the 5 squared over 2 minus 2 times 5, and here will be minus the evaluation with the other number, will be 2 times -1 to the third over 3 plus 3 times -1 squared over 2 minus 2 times -1. There it is. Now we will have to simplify this out. Equal here, and well, here will be 2 times 5 to the cube. It's 125 over 3. Will be 3 times 25 over 2 minus 10. Here I'm going to use the minus sign. I'm going to solve first here. -1 to the third will be here negative 2/3, here will be plus 1 squared. It's just negative 1 squared will be 1 positive, so it will be 3/2. Here will be positive 2. There it is. Now I'm going to take away this the sign here. Here will be 250/3. Here will be plus 75/2. Here will be minus 10, and here will be plus 2/3 plus 3/2 plus 2. And now from here I'm going to use a calculator. Let me see. Oh, sorry, I have to correct something here. This has to be a negative one. So this one. So let me see. It will be here minus and minus. There it is. And then at the end we got let me see, this is equal to 108 units squared, which is basically the result we got from the Riemann sum. If you would see it in a graph, I'm going to use here my super skills for drawing. If you will see a graph, let's say you have here, just very ugly, this is the x-axis, you have here the y-axis. For example, this graph, I don't know, will look something like this, for example, and then you would have the interval between -1, which is here, then -1, and I don't know, here, for example, 5, and these 108 represent just as well as the Riemann sum case this area that would be below between the function and the x-axis, and that will be it with this example.